All right, so to continue on in section 3.3, again, we're thinking about skewed distributions in the section. So the next thing we want to talk about is resistance. A numerical summary of data is said to be resistant if outliers, either very large or small values, do not affect its value substantially. When outliers are present, the median is a good choice for measure of center. It is not affected by the size of an outlier and does not change even if a particular outlier is replaced by a more extreme value. So what we say is that our numerical summary, if we're using the median is more resistant than the mean. Because if we have an extreme value, an outlier value, it can affect the mean a lot more than it can affect the median. And that's what we're going to see then in this next example as we look at resistance. So the following data represent the travel times and minutes of work for all 7 employees of a web development company. We've actually worked through using this example. So just a little refresher, our mean and our median from previous examples. To find our mean, remember we add all of these values up. If we add all of those values up, we got 174. We divided by a total of 1, 2, 3, 4, 5, 6, 7. And that gave us approximately, I'll throw a little wiggly equal signs in there, 24.9 minutes for our mean. Right, that was back from section 3.1. And then in this section, in example 2, we looked at our median. We listed these guys in order, and our middle value was 23 minutes. So if we list these in order, remember that 23 minutes was the value that we got in the middle. All right, now for B. Suppose a new employee is hired who has a 75-minute commute. Find the mean and median of the new list of 8 employees. All right, so 75-minute commute, a lot different than the values that we have in here. We could say that the 75-minute commute is an outlier. Right, so now we're going to recalculate our mean and median and see what happens. So as far as our mean goes, I'm just going to take my total from my previous example, this 174, add 75 to it. This time instead of dividing by 7, we have 8. So we're going to get 249 divided by 8, which gives us approximately 31.1 minutes. So this new large value has caused our mean to go up significantly, a little over 6 minutes to 31.1 minutes. All right, for our median. All right, so we're going to list these guys in order. So we had 5, 18, 23, 23, 26, 36, 43, and the new person at 75. Now instead of having an odd number of values, we have an even number. So we're going to take these two guys in the middle and average them. 23 plus 26 gives us 49. 49 divided by 2 gives us 24.5 minutes. Right. So we have our original values for our mean and our median, and then we have our new values with this new employee for both our mean and our median. All right, so part C. How does the new employee impact the value of the mean and the median? So we're going to say the new employee greatly impacted the mean because our impact on the mean was about 6 minutes. Again, actually a little bit more. But they only slightly impacted the median, because our median went up from 23 minutes to 24.5 minutes. Right, so this was only 1.5 minutes. Right, so comparing the two, our mean changed a lot. Our median did not change as much. So to kind of tying this all together and finishing up the idea that we started with at the top of this page, the idea of resistance, we're going to say that the median is resistant to the outlier of 75 minutes. And if we want a little bit more of an explanation, we can say because it increased or changed by less than the median did. So the idea of resistance, the median is more resistant to change because our median does not change as much as our mean does if we have an extreme outlier. This can be a very large value, as we saw in this case, or it could also be a smaller value, as we might see in some other cases.